Okay, Coroneos 100 integrals, number 32. So we've got this question here. That's 1 over 1 plus cosine square x. How do we integrate this one? You've got two different ways of doing this question. Eventually you get the same answer at the end. The first method is actually called T formula substitution. So you can actually change this one into the double angle formula, and you can let in T equals to tangent x on 2 to do this question. But however, I would like to show you the method where it's pretty interesting. Using the algebra manipulation, we can also do a question like this one here. So what we're going to do is we're going to divide both the top and the bottom by cosine square x. So we're going to divide both the top and the bottom. Divide here by cosine square x. Divide here by cosine square x. All right, the reason I want to do that is I want to change everything in terms of sector x. Okay, so we can use the formula, the Pythagorean identity in terms of sector x and tangent square x. All right, so let's do it. So that gives us 1 over cosine square x over 1 over cosine square x plus 1 dx. Now, of course, we know 1 over cosine square x is equal to sector square x. So we'll get sector square x over sector square x plus 1 dx. Okay, so the next step you do is the critical step. What we need to do now is change one of the sector square x, okay? It's actually on the denominator. We're going to change that sector square x in terms of the tangent. So we know the Pythagorean identity of the tangent, 1 plus tangent square x is equal to sector square x. Oh, is equal to. So therefore, we can change that into 2 plus tangent square x dx. Okay, now once you finish this, all right, this question looks very, very similar. Hopefully you realize this question is very similar to the inverse trig, and it's actually inverse tangent integration here. Because if you just write something like, for example, 1 over 1 plus x squared dx, and we know this is tangent inverse x plus c. And then if we have f dash x on the top, and that's 1 plus fx here, and this is just power of 2 dx. Again, this is just reverse chain rule for the inverse tangent, so that gives you tangent inverse fx plus c. So right now it's really, really similar. Apart from here is equal to 2 and that's equal to 1, but we can deal with that, okay? So that's not really a concern. That's really easy because there's another formula for that. If we have, for example, a squared plus fx squared dx, all right, the answer will be 1 over a tangent inverse fx over a plus c. So this is not really a big deal. All right, so now if you pay attention to what we have here, both the top and the bottom, it looks very similar to the formula. Really, really similar, okay? If you can't see it, what I can do now is to just emphasize the fx. So I'm going to change the brackets like tangent square x in terms of something like square bracket square. So if you pay attention to what's inside the bracket, we've got tangent x. The derivative of tangent x is equal to sector square x, which means that's just the formula fx, and we've got f dash x on the top. The derivative of fx is just f dash x. So therefore, that just gives you the answer 1 on square root of 2. Now, this is something that's really important. You need to remember to write this one in terms of square root of 2 square. So therefore, the a is equal to square root of 2. All right, and that gives you tangent inverse tangent x, which is the fx, over square root of 2 plus c. Okay, so that's the answer to that question. You may also wish to do this question using the T formula substitution. It is still going to get you the same answer at the end. But I feel like this is a bit easier. But of course, the algebra manipulation, as the first step is the critical step, all right? If you don't know that you're going to divide both the top and the bottom by cosine square x, then it's kind of like, you can't get to this point. So therefore, maybe you will just do the question using the T formula substitution. But I'm just offering you another pretty good method to use, okay? Thanks for watching.